So modeling a futures contract on gold, say, in this example, so we have, we're going to have a K of 300. You can see we have an initial price of gold of $300. We're going to have a sigma of 10%, a risk-free rate of 5. It's a 1-year option, and we're going to split the period into thirds. So H is a third. So we can then note that 300, what's U? U is equal to 0.1 e to the 0.1 times square root of a third. And D is equal to e to the minus 0.1 square root of a third. And we can see correspondingly the price of gold, or the price of the futures, goes up to 317 or down to 283 in one period, and that continues. So now we have an option, a call option on gold, and we have a strike of 300. So we can see the exercise values here come directly from that exercise. And we can see that we have an early exercise here, and that's because at that time the exercise value, which is 3672, exceeds the expected present value of these values. Using P star, and we saw a minute ago that P star is just 1 minus a D over U minus D. And some people find it easier to remember how to model futures by thinking that this looks just like the P star for a currency or the P star for a stock with continuous dividends, if we make the assumption that in the continuous dividend case that R is equal to delta or R is equal to RF. In other words, in the case where the return on the stock, which is delta, or the return on the foreign currency, RF, is equal to the risk-free rate, the P star will have this same formula, 1 minus D over U minus D. And that's intuitively, that makes sense intuitively, because a futures contract, one can think of the futures contract as having return R over time, simply because the futures price equals the forward price, and the forward price grows at the rate of R as you move through time. So this is an easy paradigm in terms of remembering what P star looks like compared to the earlier formulas for P star, where we had on the one hand a stock with continuous dividends, on the other hand a foreign currency earning its own risk rate. So the motive for early exercise of an option, you might wonder, well, mathematically we see from this earlier diagram that we had an earlier exercise at this mode. So what's the value of early exercise on an option on a futures contract? Well, when you exercise an option on a futures, you get a cash. So in this case, what I would receive is I would receive $36.72 and a futures contract with a futures price of $336.72. So when you exercise a call on a futures contract, you really get two things. You get the cash amount, but you also get a futures contract at the then current futures price. If you don't want the futures contract, you can just liquidate it at no cost by reversing it, and then you just have the $36. So the point of this next slide is that the motive for early exercise is you get your hands on the mark-to-market. You get your hands on the exercise value earlier, and you can then invest it in whatever appropriate investment. Options on bonds are addressed only indirectly in this chapter because they'll be coming up in more detail in a later chapter. So just to say, bonds have many of the same characteristics as stock in the sense that they pay discrete dividends. So a stock and that pays discrete dividends, and a bond, one would guess, have a lot in common. But there is a difference with bonds that needs to be accounted for, and that is that the volatility of a bond decreases as you get close to maturity, simply because a bond has to mature for its par amount. So as you get close to maturity, its price volatility must decline because the price must converge to its par value. We also have to be careful about the assumptions we make about interest rates at different maturities. And that is that simplistic models of how interest rates behave for different maturity bonds can often lead to arbitrage opportunities that we'll see in a later module. So here's a summary. And this summary is a good way of thinking about the P-star formulas, namely that the general formula for P-star is an E e to the R minus, I'll just call it delta H minus D over U minus D, where delta is the dividend rate on a stock. So this is the risk-neutral probability on a stock with continuous dividends to pay delta. And what this table is suggesting is that you can use this formula for other securities where for a stock index the dividend yield is just the dividend yield. For a currency, I can use that formula but make the dividend yield equal to the foreign risk-free rate. On a futures contract, I make the delta equal to R. Commodities we'll ignore because they're not on this particular exam. And for a bond, it would be the yield on a bond, logically, just as it is the yield on a stock. So it just gives you a simple way for the three most important contracts of this chapter of remembering what P-star is. And of course, if one's dealing with a stock with no dividends, then delta is simply 0.